Hi, I am Varun Joshi and welcome to the first lecture of our Argo CD Basics to Production course. Before we jump into tools like Argo CD, it is important to first understand what GitOps actually is and why it exists. GitOps is not just another deployment tool or a CI/CD pattern, so to speak. It is an operating model that changes how applications and infrastructure are managed using Git as the single source of truth. In this lecture, we will understand why GitOps was needed, the problems teams faced before GitOps, and how concepts like pull based deployments, continuous reconciliation, and repository ownership solve those problems. We will also separate application pipelines from configuration pipelines, which is foundational for everything that follows. This lecture sets the mental model for rest of the course. So let's get started. Why GitOps? Now, firstly, before discussing anything, let's sort one thing clearly. When I talk about your application code is properly version controlled and it adheres to the Git discipline. So, for example, you see app1 repo here, and there are developers who will be pushing and pulling based on their needs, and then it follows the hierarchy as well. For example, if someone wants to work on a feature, he or she will be creating a feature branch, and then on that feature branch all the changes will be performed, and then a PR will be raised to the main branch if you are adhering to trunk based workflows, or to an environment specific branch if you are adhering to git flow based branching strategy. Again, in production implementations, your environment branches and your main branches will be protected, so you will not be able to push directly onto those branches. You will be pushing onto feature branches and then raising pull request for the merge to happen. Again, we have discussed these concepts thoroughly in our CI/CD series. If you want, you can refresh your memory. We discussed that there are two branching strategies. There is git flow based and there is trunk based. Git flow will have environment specific branches, and trunk based will only have main, which will be the single source of truth. And then both of these have feature branches which developers or DevOps engineers will be creating based on their requirements. Now let's go back to GitOps. So application code was properly version controlled. So how things looked: application code managed in Git with branching, PRs, reviews, and tests. Infrastructure, although it was defined as infrastructure as code, but it was applied manually. Understand what we are saying here. We are saying we are using IAC, maybe you are using Terraform, but those configuration templates, those Terraform templates are not version controlled. They are lying in someone's laptop or scattered across DevOps teams. What I am trying to convey here is the infrastructure template or your Kubernetes manifests or your Ansible playbooks or your chef recipes or your Puppet manifests or your customized templates or your Helm charts all were scattered in DevOps folks' workstations or into their jump hosts, which is not what we want. We want the infrastructure templates to also adhere to the same strategy that application code uses. And what is that strategy? That strategy is we want everything that is supporting the application to run properly. be also version controlled. Hence, we want both infrastructure and configuration level things to also adhere to the same principles of Git, which is branching, PRs, reviews, and test. So as of now, things did not look like this, at least for infrastructure and configuration files. And when I say infrastructure, I imply your Kubernetes cluster itself, or your traditional virtual machines, or anything else on which your application runs. Then configuration is essentially your Kubernetes manifest and op config. Now op configs, as in, you can think of these as Ansible playbooks, chef recipes, puppet manifests, and so on. So both of these were outside of Git flow. What we are saying is we want these also to be version controlled. Now, what are the challenges if there is not a unified model? First is no single source of truth. Now, if you are not using Git for your infrastructure and configuration, then of course there is no single source of truth. Second is desired versus current state mismatch. Now understand, there is a Kubernetes cluster, let's say, and then there is a Git repository. For this example, let's say you have version controlled your Kubernetes manifest. So what you have done is you have defined the desired state of your Kubernetes workloads in your Git repository. So let's say you have defined you want 5 replicas for app 1, and then there is a cluster which has deployed your resources. So what is running in the cluster is the current state. What is defined in Git is desired state. Now someone walks up and changes the current state, that is, someone went and edited the deployment to have 3 replicas, but what you defined was 5 replica. And always what you have defined in your configuration is your desired state, not what you have applied or what you have edited in your cluster. And this not just implies for Kubernetes, this implies for Terraform as well. What you have defined in your Terraform template is the source of truth. If someone changes the infrastructure manually, then there is a drift. Similarly, if I have defined 5 replicas in my Git repository for my deployment related to application 1, and someone manually changes that in the Kubernetes cluster manually, then there is a mismatch. The desired state does not match the current state. This is a problem for me. Now understand, there are 2 challenges we are discussing here. I want you to pay clear attention. First is, we are saying the infrastructure and configuration files were not version controlled. That is challenge number 1. Challenge number 2 is, even if they are version controlled, there is nothing which would take care or ensure that the desired state matches the current state, because once you have applied that configuration file onto your Kubernetes cluster which warranted 5 replicas, and there is the current state which only has 3 replicas, there is no one who could sense that something has changed and something is not in line with what is defined in Git. We do not have that definition. So these are the 2 clear challenges. First is, infrastructure and configuration files were not version controlled. Secondly, if they were version controlled, there was no one who could check that whether the desired state matches the current state. And again, desired state is defined in Git and current state is what is running in your cluster. The next point is weak audit and rollbacks. And this is true. If you are not version controlling anything, then how do you track that, okay, this application resulted, or this Kubernetes deployment resulted from this commit ID? If you do not know, then your auditing becomes really weak. And rollbacks are another challenge. If you have changed something manually, how will you roll back? You will have to have manual methods to roll back. And firstly, you should know that someone has changed something to roll back, and that feature is not available because there is nothing that is comparing the desired state with the current state, or the current state with the desired state. And then rollback is not just this. If you are not version controlling your config files, you do not know where to roll back, because there could be 10 DevOps engineers and you do not know whose configuration file to trust, who is holding the configuration that that application demands. So rollback is a challenge in both the scenarios. If you are not version controlling thing, then also rollback is a challenge. If the desired state is not matching the current state, then also rollback is a challenge. Difficult to trace changes and revert safely. Then you have environment drift. So you have created manifest files for dev environment, stage environment, prod environment, and after repeated manual changes, all these are running different things. You do not know what was the initial state or what is the state in which the application is now running fine. All of these things are manual, and trust me guys, I have been there. If your configuration files, Kubernetes manifests are not version controlled, sooner or later it will come to you, and no one will hear when you say this was not done by me, this was done by someone who has left the organization now. These things will not be catered. So from now itself, if you are not version controlling your Terraform templates or your Kubernetes manifests, start doing that. Then you have security risk. Now let's say you have version controlled your infrastructure and configuration files, right? You have done that. But when your CI like Jenkins would want to deploy onto your, let's say, Amazon EKS cluster, you will have to configure your CI, your Jenkins, to have access to your Amazon EKS cluster for the CD to take place, for the deployment to take place. And this is a security risk. Why would I want to provide my CI server access to my Amazon EKS cluster? And often when you are deploying things, you would want to give the deploy access, and maybe as part of your pipeline you are also deleting something, and in that scenario you would also have to give that delete access. And this looks okay if your environment is governed properly, but what if there is a leak? What if there is a pipeline triggered which should not have been triggered? So what we want is, we first want to have principle of least privilege in place, so that is all right, but we also want that our CI server should not have access to my Amazon EKS cluster. I would want something that can be done within my Kubernetes cluster to ensure that I don't give access to my cluster to my CI server or to even humans. I don't want anyone to have deploy or delete rights in my Kubernetes cluster apart from the automation that I purposefully built for it. And we will see what that automation is in a little while. I hope you understand what all are the problems. So again, I'm repeating, there were two main problems. First is infrastructure and configuration files were not version controlled. Second was, even if they were version controlled, there was no controller which could check the current state matches the desired state. Now with this understanding, let's go to the next section, which is what is GitOps by CNCF. Now there is Open GitOps. Open GitOps is a project which is catered by CNCF. It falls under the CNCF umbrella. So what I have done is I'm giving you the definition of GitOps as given by them. It is an operating model. Again, GitOps is not a tool which you can buy. It's a methodology. It is an operating model. It is like DevOps, DevSecOps, all of these things. These are cultures, these are methodologies, these are operating models. These are not tools which you can buy. You cannot touch them. These are logical concepts. So it is an operating model where the desired state of applications and infrastructure is declared in Git. So Git will be the single source of truth, and software agents continuously reconcile the running system to match that state. So understand, like I said, there were two challenges in the previous screen. First challenge was infrastructure and configuration files were not version controlled. So GitOps says, firstly, both of these should be version controlled. And second, it says that there must be a software agent that should be continuously looking at reconciling the running system. And what does reconciling mean? Reconciling means that software agent should be ensuring that what is running in your Kubernetes cluster right now matches what is defined in Git. And now I would also want to go to my browser and show you these principles. So GitOps principles, and this is the official website, opengitops.dev. It says declarative, versioned and immutable, pulled automatically. This is important. So if there is a change in your Git, your Kubernetes cluster should know that I have to pull those changes. That should work automatically. And we will see how all of these things happen slowly and steadily as we move along with this lecture. Last one is continuously reconciled, and this is important. The current state continues to match the desired state. Now let's go back to our draw.io and let's see benefits of the GitOps model. Single source of truth, we already know. Drift detection, we already know. If someone manually changes something in my Kubernetes cluster, I have a software agent running in my cluster which is continuously checking with Git whether my current state matches the desired state. So drift detection. Improved security. Now this is an important piece. Previously, if you have seen my DevSecOps mega demo, you know that we had to provide Jenkins user access to my Kubernetes cluster to deploy resources. But when you are using GitOps, you do not have to provide your CI/CD pipeline or your CI/CD orchestrator like Jenkins, GitLab, or your GitHub Actions access to your cluster, because there is an agent already running in your cluster which is directly checking your Git repositories to see if there has been a change. If there has been a change, those changes are automatically rolled into your cluster, and we will see this workflow in a little while. Audit and rollback. Since everything is governed by Git, we can say that it is auditable by default. And rollback, this made me the happiest. I'll tell you why. Let's say you rolled out some change, you changed something in your Git, and your configuration resulted in your cluster breaking. Maybe your application didn't work properly. Now what you can just do to roll back is you can just run git revert, and your software agent, which is continuously scanning your Git repo, sees that and does a rollback. So no extra terminals, no extra jump hosts, just one command, git revert, and you are back to your happy state, which is so cool in my opinion. And then the next one is clear ownership. Shared application build responsibilities. DevOps manages platforms and infrastructure. And I will zoom in into this clear ownership part in the next slide. So let's not discuss this here. Next is consistency at scale. Same model across teams and environment, and this will make your life so much easier. When I first learned about GitOps, I will tell you that I was dealing with multiple projects at that point of time, and I introduced this GitOps in every project. So no access to your CI systems, your software agents, which are also called GitOps controllers, will ensure whatever is defined in Git is reflected in your Kubernetes cluster, because we know GitOps is a methodology where changes are pulled automatically and are continuously reconciled. And I want to plant a term in your head right now, because we'll be discussing that later. Previously, when we were using, let's say, a CI CD orchestrator, what we were doing is we were pushing the deployments. And how we were pushing the deployments? We were running commands like kubectl apply, or running helm or customize specific commands to deploy resources onto our Kubernetes cluster. We were pushing things, but here we are pulling things, because there is something in our Git which our software agent is pulling and deploying onto the Kubernetes cluster. So understanding this at this stage will ease the next part. So let's go back to our diagrams, and we have understood clearly what is GitOps and what are the benefits of GitOps. Now let's see what I want to discuss next. Now understand, I said that everything must be version controlled, be it your application code or be it your configuration files that are supporting your application. So for example, I will have two repositories, and this is a best practice. You can have a single repository, folks, but the best practice, the recommended approach, is to have two separate repos. One repo is often called application repository. This will of course hold the source code at large, and then there is application configuration repository. So configuration is the keyword. So configuration is something on which your application will depend. So for example, Terraform templates, Ansible scripts, and all of these things, if they are not there, then there will essentially be no infrastructure for application to run, which is why this is called application repo, which makes sense. And this one is called application configuration repo. I hope this distinction is clear. I want to plant another concept in your head right now. You will have two different pipelines. One pipeline will cater to application repo, and another pipeline will cater to the application configuration repository. So now with that mental understanding, let's deep dive into both of these concepts. So purpose: build, test, and package application code into a versioned deployable artifact. So we are discussing GitOps, so I will talk in terms of GitOps. So here the points that I have mentioned, they can apply to application repository. Some points will apply to application repository, and some points will apply to application repository pipeline. Understand, we are segregating repositories into two bifurcations. So one would only hold application code, and there are other files that will be there, and we'll discuss about them. And then there is the application configuration repository, which will hold the configurations that will help your application run properly. We understand this, but also know there must be an orchestrator that is dealing with what to do with whatever is there in the application repository. And there must also be a pipeline, essentially an orchestrator, and there you will be creating a pipeline which will decide what to do with the files that are available in the application configuration repository. Now, application repository, the pipeline that you would be creating for application repository will be responsible for building, testing, and packaging application code. And we have seen this a million times in our CI/CD series. Again, purpose is to create a deployable artifact. We are not talking about deployment itself. We are just talking about an artifact which can be deployed somewhere. We are not deploying anything in our application repository pipeline. Engrave this thing in your mind at this stage itself. Then contains application source code, which is understandable. It will also be doing tests. If you have your pipeline, it will be doing tests. For example, for compiled languages, you would be using build tools which will be helping you with these tests. And also for interpreted languages, you have tests like PyTest, npm test, and so on. So you will be testing. You will have Docker file. This is important. So contains application code and tests. So both of these things will be defined by developers, your application teams. But there are also things that will be defined or catered by you as DevOps engineers. So what are those things? Docker file. Now the primary ownership of Docker file is mostly with application teams, but do not think that these are solely their responsibility. You may also be consulted to refine the Docker file, just giving you that basic understanding. But 99% of the times it is application teams who will be handling the Docker file. Then CI pipeline definitions. Now what are these? Your Jenkins file. If you are using GitHub Actions, it will have its own YAML file. If you have GitLab, it will have its own YAML file. If you are using AWS, it will also have build spec.yaml. So your pipeline definitions will also be stored here, because pipeline definitions are something that your orchestrator will be using to decide what to do with this code. And that thing is defined in the pipeline definitions. An example is Jenkins file, and other tools will have their own respective YAML files. And build test scripts. Of course, you will be defining your SonarQube tests, your SAST, your DAST, your SBOM, your image scanning. All of these will be defined in these pipelines itself, or they could be defined separately as well. So this repository will contain all these things. Now, we have not discussed Kubernetes manifests or Terraform templates or Ansible playbooks or Chef Puppet, anything. We are not discussing those. Here we have the application code, Docker file, CI pipeline definitions. Then comes the ownership. Now understand, this repository will have mixed ownership, shared ownership, but the primary owner will of course be application team. But you as DevOps folk will be raising PRs, because it is often that you will be changing your Jenkins file or your CI pipeline definitions, or you are defining new tests within your build tool or something of that sort. So you will have ownership, but your ownership will be secondary. Primary will be your developers or your application teams. Now let's discuss application configuration repository, app config repo, and we'll also be discussing application configuration repository pipeline, a pipeline that will taking care of the files that reside in this repository. Purpose: define and control how approved artifacts run across environments. Understand, here the purpose was to generate the artifact, correct? And here that artifact definition must be available for your software agent to pick. Understand, I'll give you an example here. Let's say here a container image was created. Here is your Kubernetes manifest file, let's say. Now, Kubernetes manifest file must have the version of that image, correct? And that version is defined here, because here you have your Kubernetes manifest, Helm charts, customized bases and overlays, Terraform CloudFormation templates, and configuration management definition, Ansible, Chef, Puppet, etc. Ownership is primarily with DevOps, and in most scenarios, 99.99% of the times, you will be the sole owner of this repository and this pipeline. Even this pipeline will be owned by DevOps, but when I talk about repository, the repository ownership will be with developer. Here, the repository ownership will be with DevOps. Now, there could be certain gray areas in your project, but at large, you understand what is the purpose of these repositories and the pipelines that are associated with these repositories. If there is some confusion at this stage, it is all right. Next, I have a detailed architectural diagram which will help solidify your concepts. So let's see what I want to discuss next. GitOps workflow from code to continuous reconciliation. CNCF GitOps perspective. So let's first see what is happening in this diagram. We have two pipelines. One pipeline is this, and this pipeline is associated with application repo. And one pipeline is this. This pipeline is associated with your application config repo. This part is understood. And we already know application pipelines publish artifacts, generate artifact, and then publish. They are not deploying. This is a key concept here. Second is Git declares the desired state. We know that application repo holds the desired state for the application, and application config repo holds the desired state of your infrastructure and configuration files, primarily your Kubernetes manifest. Now, at this point of time, I want to tell you one thing straight away. When I talk about Kubernetes, if your destination for deployment is Kubernetes, there is a GitOps controller, and these GitOps controllers are Argo CD and you have Flux CD. But these are limited to Kubernetes. Understand? Because you will also have Terraform templates, you will also have Ansible playbooks. Now, who is ensuring that the state of the Ansible that you have defined in your Git repo matches the configuration that your application is running? So here for Ansible, we are not saying that we have a tool right now that supports this reconciliation. You can, of course, have them committed in your Git repo, and that you should. All your infrastructure, be it Terraform, be it Kubernetes, be it Ansible, Chef, Puppet, all of these must be version controlled. But the second point that is extremely important is this one, what we discussed here: pulled automatically, continuously reconciled. Both of these things are right now only mature for Kubernetes. These both are not mature enough for your infrastructure or for your other configuration components. For Kubernetes, we do have. So there is also, someone is saying, Varun, there is crossplane for infrastructure, right? But crossplane is not true GitOps. So what crossplane would do is it can, create resources or manage resources across cloud providers, because it uses Kubernetes CRDs as the source of truth. Okay, if you change something in your Kubernetes custom resource definitions associated with crossplane, it will make that change in your infrastructure. But their Git is not the source of truth for crossplane. It is what you are defining in those CRDs. That is the source of truth. So if I have to tell you that is it GitOps, it is not true GitOps, because we know what GitOps methodology says. It says everything must be versioned and immutable, declarative, and then all these things must be pulled automatically or continuously reconciled. So for Kubernetes, we have a true GitOps controller in form of Argo CD and Flux CD, and there could be more tools. But for other components, there is no true GitOps controller at this point of time. Now, you might be thinking, but Varun, why is there a tool for Kubernetes? Why can't we create different tools? And understand, if you are dealing with Terraform, you still have to run Terraform plan to see whether your current state matches the desired state. So desired state is what you have defined in your templates, and current state is what is running in your infrastructure. There is a way, but there is no controller who is continuously monitoring that. Of course, when you manually run Terraform plan or Terraform apply, it will tell you that the state is not matching. Of course, manually it is there. But when I talk about a controller who is there just to ensure that the state matches, that thing is not there. So why it is there for Kubernetes? Now understand, Kubernetes already has different controllers. Hello, you have seen deployment controller, right? Deployment controller and replica set controller, these are already ensuring that if someone has defined 5 replicas are already running. So it is easier to integrate GitOps controllers with Kubernetes than other tools that are available in the market. So in essence, it is easiest and most natural on Kubernetes because Kubernetes itself is built around reconciliation. That is the reason. So let's now get back to that diagram. Application repo pipeline, developer change. So let's say there is a developer who modifies the application code. Okay. Now we know as a best practice that once this code is modified, this will be pushed onto a feature branch because your main or your environment branches are protected. So you cannot push directly to those branches. Now in the feature branch is there to isolate changes in feature branches, and then a pull request is created. So once the developer is happy with the code in the feature branch, developer will create a PR. Now for this PR to merge in production pipelines, there will be several checks, and those checks are orchestrated by your CI/CD orchestrator, which is typically your Jenkins, your GitHub Actions, GitLab CI, and so on. So in this example, I have taken Jenkins as an example. So as soon as the PR is raised, a webhook will run the Jenkins pipeline, and Jenkins pipeline will be building the code if it is for compiled languages, and then the testing will be performed, the scanning of artifacts would be performed. So all these things, SAST, DAST, all of these things will be orchestrated by your Jenkins, your CI server. And then you will also have build tools here who will be helping you with your compiled languages. Now, if these terms are alien to you, again, I would recommend you to watch my CI/CD series where we have discussed this Git flow, trunk flow, and all of these things in extreme detail. So if I look at this lecture, the day one, we discussed about what are interpreted, what are compiled languages, how SDLC looks like. So it is imperative that you have this understanding before attempting GitOps. Because what is GitOps? GitOps assumes that you have a pipeline, you have a Git repo, and all of these things already set up so that you can leverage the methodologies, the principles that are defined under GitOps by open GitOps community. So let's take this further. So this will do, and once these tests, once this pipeline succeeds, only then the code will be merged with main or your environment branches. Again, you could also have a manual approval stage here, which I have not shown. And let's, for this example, say the merge happens without this manual approval. So once it is here, PR approved and merged, artifact marked approved but not deployed. So this is the key distinction. So we have the artifact with us now, and we must publish that artifact somewhere, and that somewhere is typically your image registry if I'm talking about containerized workloads. And since we said that true GitOps is only applicable when the destination is Kubernetes cluster, we can be assured that you will be using Argo CD or a GitOps controller, proper GitOps controller, at least at this point of time, only when your destination is Kubernetes. So here what we are saying, we have published the artifact, we have published the container image onto an image registry like Amazon ECR, Docker Hub, and so on. No Kubernetes cluster changes yet. Push image to artifact image registry. This pipeline has done its job up till here, that was to publish the artifact. Now, the interesting part. Someone is thinking, Varun, this is fine, but how do I trigger my next pipeline? And my next pipeline is application config repo, because we know our configuration files for Kubernetes, the manifest files, live here. So what we want to now do is, here would be a file for my deployment, and there I want to change the image version to whatever I have defined here. And understand, in production implementations, you would be changing not the tag but the image digest. So there are two ways. In lower environments, in development, you could use tags, and which we have been using thus far in this course. But in production implementations, you would not see tags being used. What you use is image digest. So if I go to my browser here, I have opened an image here. So this is my repo name, app2 flask, and this is the tag. But when I want to pull this image, I won't be using this tag, because tags are often mutable. What I want is image digest, manifest digest, which is truly immutable. If you change one bit in your image, this digest will change. Here with this tag, human errors are possible, but with this image digest, human errors are not possible, which is why in production implementations, always the image digest is used to pull the image. Now let's say we have published the artifact. Now in this repository, we want to make change in the configuration file, in the Kubernetes manifest of that deployment. How do I make that change? Because once I do that change, only then the new version, whatever I have defined here, whatever I have created here, will be deployed onto my Kubernetes cluster. But how do I do that? Now, let's take this everything out for now. If I were to change something manually here, what I would do, first I will make the modifications. I will change the repo tag or repo image digest, and then I will push the changes onto a feature branch, right? And once my changes are pushed to a feature branch, I will be raising a PR. As soon as I raise a PR, here there will be no build. Understand, we are not building a software. We have these static files here. We don't have to build those static files, right? The static file just needs to be updated with the correct version information. So as soon as I raise a PR, what will happen is, because we have to do some sort of validation, right? We cannot just merge the change onto main or environment branch. What happens is, as soon as you raise a pull request, there is an ephemeral environment created. Now, do not think of an ephemeral environment as an entire Kubernetes cluster. This ephemeral environment could just be a temporary namespace, and in that temporary namespace, you deploy your application and you see whether your application works fine. So here is the point where you will be configuring all those beautiful things, your readiness probes, your liveness probes, your startup probes. And when all of these things are successful, and maybe you are performing a quick smoke test of the application, whether the application is accessible or not, or whether it is performing its primary function or not. And then once this testing is performed, only then the code is merged. Only then the version is updated in the main branch or your environment branches. And once that is done, that ephemeral environment is decommissioned. So that's how the validation is performed. And once the code is merged, hello, there is someone like Argo CD controller or your Flux controller, which are essentially GitOps controller, is continuously watching your Git repository. And as soon as it sees there's a new version of the application, it gets to work. And that is what we discussed here. We said it pulls changes automatically, and here it is pulling those changes. Another thing is, If someone changes something manually in your Kubernetes cluster, for that deployment file that is already being tracked by your GitOps controller, that Git repository is already being tracked by your GitOps controller, it detects runtime drifts, auto revert cluster to Git. So whatever is defined in Git is the single source of truth. This part I'm sure 100% everyone has understood. But the question then becomes the primary question, the handoff. We defined what will happen if we do this manually. But the question is, how will this inform this pipeline to trigger? How will that happen? And my friends, that is where your CI will be doing this. What your CI will do, once this artifact is published, you will configure your CI to clone this repository, correct? Make the changes, push the changes onto a feature branch, and then create a PR request. And upon creation of that PR request, whatever we discussed before happens in the same sequence. So the only thing in manual versus pipeline getting triggered because of this is, here it is done by a DevOps engineer, manual changes are performed by a DevOps engineer, and here the handoff happens by, let's say, a Git user or a Jenkins user who will be doing all these things what a human would do in an automated fashion, which is why I have this point here. App config repo pipeline is triggered by two things: developer driven pull request, which we saw here if developer made a change. And understand one more thing, in this pipeline and in this repo, primarily from a DevOps perspective, only the image tag will change, nothing else. I mean, of course, there could be exceptions, but when you upgrade an application or make changes in that application, all those changes are contained in your container image, and that container image has a tag or an image digest. So essentially, whenever application teams or application repo will have change, they will be just changing the image tag. So when this happens, developer driven pull request, application code changes, and it is only the tag that will change, nothing else. And that is understandable. But DevOps driven pushes, if I am a DevOps engineer, I will not be catering anything here because I want to make changes in something. And what could those changes be? I could be changing maybe the requests and limits. Maybe I am, creating a new namespace. Maybe I'm creating a deployment. Who knows? Whatever I, DevOps engineer, want to be there in my Kubernetes cluster, I'm doing those changes. Maybe I'm creating a network policy. Maybe I am creating a config map, and the list goes on and on. In that scenario, if DevOps person wants to make a change, he or she won't be adhering to this hierarchy. He will just make the change here, and then in the feature branch, she will push the change, and then validation will happen and the change will be deployed onto your Kubernetes cluster. So that is how this will work. So understand two flows. One is developer driven, which we discussed. So all of these things will happen. And one is DevOps driven, where only this will happen. I hope this makes sense. Now, with this understanding, I want to discuss two methodologies which I discussed initially as well. Deployment models. There is push based and then there is pull based, and we have been dealing with push based since the inception of our CI/CD course, and that is very traditional. You handle both CI and the deployment part in your CI/CD pipeline, and in our mega project as well, we did that. We deployed our Kubernetes manifest onto our Kubernetes cluster, and that required Jenkins to have access to our cluster. So deployment occurs via CI/CD pipelines, pushing changes to environment used when traditionally or GitOps is not adopted. Again, push based, pull based. Pull based is GitOps and push based is traditional CI/CD. Key trait, event driven, one time execution. And we know that. So if my pipeline has deployed something, it is not monitoring that. It has done its job and it will rest until and unless someone re-triggers the pipeline. Key trait, that's why event driven. So if there is a change in the repository, then the pipeline will trigger and deploy again. But there is no one who is constantly monitoring the Git repo. There is no GitOps controller here. So one-time execution. Security model, CI holds environment credentials that we have already discussed. So Jenkins will need credentials to your Amazon EKS cluster if you're deploying to Amazon EKS via Jenkins CI. And similarly, GitLab and GitHub Actions would also require the same. Failure recovery. And this is where GitOps shines. I told you, just hit git revert and you are done. Here, you would make the configuration change again in git repo, and that will result in rerunning of the pipeline. So manual redeploy or pipeline rerun required. So this is what we have seen a million times. Then there is pull based. That is the new one that we have seen thus far. So we have just seen the architecture, folks. Do not worry, we will have detailed demo where we'll be discussing whatever we have discussed in the workflow in the demo as well. I strongly believe that your foundations must be strong, and foundations will only be strong if you can envision what you are deploying, and you can only envision what you are deploying when you have done walkthroughs like this. So you can imagine in your head, okay, I have done this, now I should be doing this, and so on. So pull based is GitOps. Deployment occurs via GitOps controllers, pulling desired state from Git. And here is where your Argo CD controllers, your Flux CD controllers shine, used for runtime and environment state enforcement. And this is the key word here, enforcement. So it ensures, it enforces what is there in the Git is also there in the cluster. So no Varun can walk in your Kubernetes cluster and make some changes which are not defined in Git. Even if he does do any change, those changes will be auto reverted. Then key trait, continuous reconciliation and drift correction. We have seen this. Detection and correction both will happen at same time. Security model, no external system pushes into the cluster. It is your cluster which is pulling something. And we will see how this happens when we discuss Argo CD in detail. Failure recovery, automatic self-healing to last known good state. And this is so awesome. Just one command, git revert, and you are good. I hope you have a strong sense of what is GitOps. That brings us to the end of the first lecture in our Argo CD Basics to Production course. You now understand why GitOps exists, what problem it solves, and how it differs from traditional CI/CD driven deployments. More importantly, you should be clear that GitOps is an operating model, not a tool, and that tool like Argo CD exists to implement and enforce this model. Argo CD in itself, it is not GitOps. It is something that helps you ensure GitOps principles are adhered to. In the next lecture, we will start building on this foundation and see how GitOps is implemented in Kubernetes and where Argo CD fits into the picture. If you have any questions, feel free to drop them in the comments and I will be happy to respond. If this lecture helped, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much.